you can review this later, and folks that missed it are able to will be able to watch it. So I'll introduce Amy Steiker, who's one of our data use and education lead, and that's the group, the team that's kind of leading this, setting up tools and services to work with data in and out of the cloud. So Amy will give a short presentation, and then Andy Barrett, who's got two hats, both as a UWG member and a DAAC representative that helps, a member of the data use and education team. So so without further ado, I'll pass it over to Amy and take over.
Great. Thank you for the intro, Walt. Okay. Let me know if you can't see the slides, if I'm in the wrong screen or anything. You should see my intro slide. So thanks again for the intro. And I really do just want to acknowledge those folks listed here. We are who are a part of our data use and education team at the NSIDC DAAC. So Walt already gave a brief intro to kind of what we'll be doing today. And really, I think in terms of sort of the goals and in talking with our group too, and hearing questions that have come up across our user community, I think what we wanted to do today, since as Walt mentioned, we want this really to be sort of a precursor to kind of some more in-depth hands-on activities and more discussion that we'll have at our fall meeting in September. We wanted this to really be kind of focusing on like the how and what does it mean to access and work with the cloud. And you know, a lot of these concepts are very abstract. So we wanted to walk through kind of both at the conceptual level and then practical level, you know, what are the differences or not between working locally and in the cloud. We'll walk through some example pathways, not only for setup, but also data usage. And then we'll transition over, as Walt said, have Andy jump in and walk through a short demonstration. So this is kind of how we broke down the session for today. I know we scheduled an hour and some of you have to drop off at the hour, but we will leave this call open for continued conversation depending on, you know, how that goes. We certainly want this to be an interactive session today. So notes on that, please ask questions in chat. Feel free to raise your hand. I would say probably, and we can kind of answer questions on the fly as we're walking through the presentation, but we'll pause after the presentation and kind of go through those questions that come up. And then, you know, we can keep it informal as well throughout the demonstration. And then, like I said, we'll have some discussion. We have a short feedback form as well. So that's kind of how we'll run things today. So team, please, you know, interrupt me if you're seeing some questions or we do need to pause during the presentation. I'm happy to address them on the fly. All right, so kind of zooming out a little bit and setting the broader context for the NASA Earth Data Cloud. I know probably a lot of this is not new for you, but it's always helpful to kind of start at this level. So just as probably, you know, reiterating some things that most of you already know, all of the NASA DAACs, including NSIDC DAAC, you know, we are continuing to migrate data, actually, you know, move bytes over to the Earth Data Cloud. This is a multi-year process, a large project, and we're all kind of at different stages as far as that migration and public availability. And I'll talk through that in the next slide as far as NSIDC DAAC in particular. A lot of the drivers for this is really, especially coming online soon, a lot of newer high resolution missions. SWAT is launching hopefully in the next couple months. We have NISAR coming online. So it's really one of the drivers for this. And we'll talk more about that in a minute as far as the sort of what the cloud can enable from a big data perspective. This next point may or may not be relevant. But the data are hosted in Amazon Web Services or AWS. Again, this is sort of a key kind of fact or statement that again, may or may not be important as we talk about kind of leveraging the cloud and working with data alongside the compute. This piece of information is important. We will talk through that more. And then DAACs, this is another important note. We're continuing to support tool services and tutorial resources for our user communities. Many of us, probably most of us across the DAAC are hard at work to support, both the kind of ingest and archive side of things, as well as the front end and user support side of things as we prepare for our public cloud data access. So that kind of moves into our schedule. I'm not going to go into a lot of detail here. We can certainly talk, and please ask questions. We can talk more about this. I think you've seen probably an iteration of this in the past. This is, will kind of continue to evolve and change, but just to kind of show that broader perspective as far as our migration roadmap, as I mentioned, this is a multi-year kind of process. And a key piece of information here is that, as I said, we are actively moving bytes, from one storage location to another. It's not an overnight thing. And that migration doesn't necessarily equal public data availability. So kind of what you see here is from that latter category of us actually moving those bytes over. It's not one-to-one with public data. This first chunk that you see on the left, and these columns indicate fiscal year, this we are preparing for kind of a subset of those data sets to be available publicly in the next couple of months. So we're still kind of in this phase of prepping and supporting for that. And these groupings are kind of based on some priorities that mostly revolve around, again, I'm not going to go into too much detail here, mostly revolve around kind of our level of service, and in particular, what data sets either currently have transformation services, things like subsetting and reformatting and reprojection, either currently supported or plan to be supported in the cloud. So that's kind of our high level timeline here. Okay, so that's broader context of where we're at, kind of from a timeline perspective and like high level of roadmap. So now we're going to switch gears and really talk about sort of thinking about our current sort of download paradigm and a cloud paradigm, and how, again, those differ or may not differ. And I wanted to start at this kind of level, abstracting, Earth Data Cloud, Amazon, all that, and just talk about really the kind of limitations and some of the impetus and then advantages that we'll move into next on cloud computing. And I really like this figure, and the same figure credited from Ryan Abernathy, who's been leading a lot of efforts in the Pangeo community as far as providing open source tooling for large, remote sensing, big data, cloud computing. And so there's sort of these two basic steps, right? We're all familiar with this. You take bytes, files that are located on premise in a storage location, you pull those over to your individual laptop, right? You are working with those files actually living on the storage that you have locally. And this kind of goes without saying, may not be a lot of use cases for this, but even today with our data sets that are only available via download, like ISAT2, take the photon level ATL03 data set, if you had any reason to download and work with that entire archive, like it's not sustainable, right? You're not really going to be able to do this at the scale that you're at your kind of laptop level as far as compute and just time it would take to get those data. So this is a pretty obvious kind of concept and limitation. But then when we start talking about kind of the advantages of then working with data in place, what we mean here is that we're kind of shifting that focus and thinking about a single kind of location for not only the files and the data that we're working with, but also that compute in the same place. So this is sort of that bubble where everything is in a particular cloud region. And then really all those, that the compute and analyses are taking place there. And really then all you're doing on your laptop is taking kind of those outputs and making pretty pictures, or making the pretty pictures in the cloud as well. And so I think a couple of the key advantages here are this reduction in time to science. And this is something that, our DAAC is always working towards and helping our users out, even in kind of a download paradigm. But, you don't have to do those steps. You don't have to do that additional local data management. And then what comes with that as well is more compute power. So, they're kind of more technical concepts here that we won't go into today as far as parallel processing capabilities and kind of scheduling workers. But the idea is that the cloud can can be very scalable and flexible. There are things like DAAC that provides these capabilities in Python. And that, again, is also a reduction in time to science just from a things are faster perspective. And then last but not least, the workflow can be fully reproducible. So the entire environment and that sort of coupling between the data and the compute, it's more tightly coupled, right? And so this is not necessarily a requirement to be working in the cloud, but this can really enable things like kind of this newer concept of executable papers where, everything kind of going from, data archive into your results are much easier to duplicate and replicate and reproduce, I should say, because of that ability to fully reproduce that environment. Okay, so that's the conceptual. But we get a lot of questions and thinking about this shift. All right, well, what does this actually mean for me? What does this mean in the context of the data that I've been working with through NASA Earth Data? So this is just a screenshot from NASA Earth Data Search. Hopefully most of you are familiar with that search and access portal for all NASA EOS data. But here's an example of an ISAT2 data set that we have in Earth Data Search available. This is also in the cloud right now. And there's still this download file option. So if I click on a granule here, I still see that link. I click on it and I get the data downloaded to my local machine. That link looks a little bit different as far as the kind of root URL. That path is still the same, and it's the exact same data that we have on premise today. I know this is big and bold, but it's really important to emphasize this point that ability, that option for direct download is certainly not going away. And there are many use cases where that's absolutely valid. We're really talking about sort of the advantages and what you can do leveraging the cloud, but this paradigm is still available and certainly suits a lot of use cases. Okay, but there's this other option. This is actually now showing a PODAC example, but that other tab, that Aws S3 access, this is what you'd also get, as far as direct access. And I don't want to go into too much jargon today. It's really easy to go down that path of like technical details and things get muddy really quickly. But I do want to talk about some of these terms because you will see them more often, right? Especially they're going to be surfaced in things like Earth Data Search and on our website. So I did want to walk through them just as sort of a quick sort of teaching moment. So you see a couple of pieces of new information here if you choose this pathway. This first section, and this is a little small, region is US West 2. This is the Amazon Web Service or AWS region where the data are stored. So this is in some undisclosed location in Oregon. The data are free as well and much faster to access, as I mentioned earlier, while also running that compute in US West 2. This next, I'm kind of jumping, but now onto the Aws S3 credentials. I'll talk about S3 in just a second, but there's also this other piece of information that is needed. These are credentials to enable that free kind of access within that region. So there are access keys that are also needed to directly access the data. This can be abstracted in libraries as Andy's going to show in a moment. And then moving back up to that middle row, bucket and object prefix. So S3 stands for a simple storage solution. You could think of these buckets as similar to file folders or store objects, which consist of the data and its descriptive metadata. So there's sort of that path. And then putting it all together, this is kind of what you see. This is an S3 link instead of HTTPS in front. That's how you know that that link, once running in US West 2, you can gain access to it. Okay, so that's a little bit of jargon going into details, but I did want to walk through that since again, it's sort of important to understand that basic terminology. So, okay, great, I have those links, but I'm on a website. What do I do with that? We can connect those links to your data analysis. You can copy paste them from a web interface like Earth Data Search. You can save them as a text file, pop them into something like a Jupyter notebook, for example, or a script running in the cloud. So that's kind of that leap going from that discovery into a cloud workflow. Okay. this is, I think, the other really key question that we get asked. So, okay, great, I have those S3 links. What the heck do I do with them? And what does actually accessing the Earth Data Cloud, when you go back to Ryan Abernathy's figure, that kind of bubble between the local data, or the remote data in the cloud and the compute, how do I get there, right? And I don't think this is exhaustive by any means, but I think this is an important point, and actually I'd love some more kind of conversation and discussion around this, as far as, right, well, what does it look like? What do I have to do as an end user? So on the left, there is an option as sort of a do-it-yourself component. And what this does mean, in order to work in place, with the data, that means creating an AWS account, creating and connecting to an EC2 instance that is essentially just a sort of compute instance that runs in that region. And we have resources for the kind of step-by-step what's needed for do-it-yourself. It doesn't have to be that way, though. And once you get into those details, it's pretty technical. So there are other options out there. What we're going to demonstrate in a moment is utilizing a managed cloud service. So there are organizations like 2I2C. This is one we're probably most familiar with today, since we're leveraging it through this NASA OpenScapes effort that many of us at NSIDC DAAC, a couple of us, are a part of. And that provides cloud-hosted Jupyter hubs for research and education. So you don't have to deal with the technical kind of background there. That can be spun up for you. And then there's potential institutional support as well. So smaller or larger scale options may exist for your research group or institution. This is a screenshot from the SMCE at NASA. And this last bullet here on NASA's funding opportunities for cloud computing, really frankly, I think could be a bullet across all of these. I think more and more of these opportunities are available, so that infrastructure is available to you, kind of from a funding perspective. All right, so I'm checking the time as well. I'll try to move through the last couple slides pretty quickly, and then we'll jump over to Andy. So that's kind of what it looks like to access the cloud. But then, okay, what does it actually look like to work alongside the data? Kind of going back to that Earth Data Search workflow. I have the S3 links, but all right, what does it actually look like for me? And I think the key kind of piece of information here, and this is just like many other cloud resources that we use today, probably with like throwing photos on Google Drive, but your preferred language and environment are connected in the back end to that remote compute instance. So for working alongside NASA Earth Data Cloud data, that is connected to that US West 2 region. And then as far as, on the front end, your preferred language and environment are set up however you kind of want them to be. These are just a few examples, but through, if you are a bash scripter, you can set up and open up a terminal prompt and connect, via SSH, for example. We can set up Jupyter Lab. That's kind of those examples I mentioned with Jupyter Hub implementations that, again, Andy's going to show, where you can work within Python and set up other kernels and have that be configured. And then something like RStudio, and actually Luis Lopez, one of our developers at NSIDC through the NASA OpenScapes group, has actually been setting this up for a couple of other scientists that we've been working with to set up RStudio that is running in the cloud. So these are just a couple of kind of examples. And then I know this question also gets asked that we wanted to touch on, which is, all right, that's great for working in a region. What does it look like to work with other clouds? And again, that whatever environment you want to work with are still kind of connected to a remote compute instance. But I think a couple of important points to note here, maybe in the Google Earth Engine example, you can jump between cloud providers. It really depends on kind of data and service availability. I know there are some services that allow kind of that connection to an S3 bucket. There are limitations that may exist, however, and I think a key point is that you're kind of then losing all those advantages that we talked about as far as analyzing in place. You're no longer kind of working alongside the data and losing kind of those additional sort of performance abilities, and you're no longer working directly with our NSIDC DAAC archived data. Not going to go into this is my last slide, and then I'll jump over to Andy. But I kind of wanted to tie this and bring it all home through something that is actually has just been in development. We haven't published this yet, but we've been talking a lot in again within NASA OpenScapes, which is a cross DAAC sort of group of mentors who are developing resources and training materials for our user communities. We've been thinking about how to provide more conceptual kind of roadmaps and choose your own adventures and cheat sheets about the cloud, because there's a lot to cover. We're not covering it all today. Again, this is just a really brief overview. So we've been developing these resources, and so trying to tie it all together, and I'm going to segue then over to Andy, where there are steps, and that everyone has potentially different workflows. Some are optional. Some data sets will have value-added services on them. Some won't, kind of depending on the level of service. But this is sort of some of some of the conceptual diagrams we've trying to help with to understand what is required if to work within the cloud, what isn't, what's sort of cloud agnostic as far as a workflow. And so this is just sort of one example that kind of tries to bring all these pieces together on, all right, setting up a cloud workspace, the authentication steps needed, and then the access, and sort of, again, what you can do to enable and leverage the sort of power of the cloud. So I have a couple of resources. Again, I'll make sure that this link for the slides gets sent out. And then I think I will end there, but a couple just plugs that, some of the tutorials that we've been building across the DAACs for various, mostly Jupyter Notebook tutorials. You can take a look here. We're leveraging some materials from the recent ISAC2 Hack Week that had a couple of great tutorials demonstrating cloud access. Andy's going to talk about this Earth Data Python library that's been in active development by Luis Lopez, our developer, one of our developers at NSIDC, and then that cloud primer that I mentioned. All right, so I'm going to hand it off to Andy, and then we'll come back and do a survey and discussion. But let me see, I haven't seen any questions in chat, unless I'm missing them. But let me pause and, see if there are, I guess, questions before jumping over to Andy.
Yeah, I mean, I don't have any questions, but it's really exciting. It's such a cool preview of what's going to come and what's going to make our workflows so much more powerful. So thank you.
Yeah, thanks, Kristen. Well, great. I'll stop sharing, and we'll jump in to Andy to actually do actually show an example here, and maybe we can have more discussion also in the context of our feedback form as well. So take it from here, Andy.
Okay. Right. Well, welcome everybody. Hopefully you can all see my screen right now. I can't see. Let me just.
Yeah, you're good, Andy.
Okay. Thanks, Amy. Right. Okay. So so what I want to do over the next hopefully 20 minutes is to just give you a guided tour through well, first of all, getting into a cloud environment, and we're going to be using a managed cloud service to I2C, which is what Amy was talking about just a few moments ago, and then give you a quick tour of Jupyter Lab in the cloud. Some of you may be very familiar with it, and it might be all old hat to you, but I just wanted to cover that quickly, and then take you through kind of a very simple kind of toy workflow of searching and accessing and then displaying some ISAC2 data. So I just thought I'd start off with just describing it more generically, kind of the managed service and what it can do to you. I'm not pushing any one vendor. Other vendors are available. So this is a managed service, so you don't have to worry about setting up your own cloud instance. There are non-profit and for-profit groups. Pangeo is another group. The idea here is that if you've got a lab or just a group of students, then you can set this up at this hub up, and all people can access a similar shared environment or the same shared environment. One of the nice things about some of the non-profit groups is that it's all open source. So you're not just tied to a single provider. You can take your environment and move that to another cloud provider or another service, not a cloud provider, although you could do if you wanted. So what does it look like to get into this? And I've created some screenshots because it can take a little time for a server to start up. So the first thing you're going to see is in most cases is that you're presented with a bunch of options to start. Do you want just a small service, or do you want to go huge if you've got a whole bunch of data to process? You select one of these options here, click start, and that will then spin up your server. And that can take a little while sometimes, but it will get you now to this point, right? And as I said, some of you are likely kind of familiar with Jupyter Hub. Obviously, there are other ways of interacting in the cloud. You can do it from the command line in a terminal, or you can use RStudio, and I think the three options, including Jupyter Hub, are probably the main options and the main ways that you interact. So this is Jupyter Hub. It's similar to Jupyter Notebooks. It's kind of a big wrapper for Jupyter Notebooks and offers other functionalities. You've got a file search capability here. You can manage your servers and your kernels. There's a few other buttons here. This allows interaction with DAAC and allows monitoring of parallelization. You can interact with GitHub, and so you're constantly checking in work. So that means that if you make a mistake, you can kind of revert back to older versions. You can also collaborate with other people. And there's a few other kind of add-ons that you can get. Then you're left with this kind of launcher thing here. You can see that you've got you can access a terminal, which is just like any other terminal if you're used to Linux. Also the command line in Windows and Mac, and that's actually a Linux terminal, but pretty straightforward to use. You can run scripts from there. You don't have to use a notebook. Start the launch as well. Then you have access to Python consoles, where you can execute Python commands, and then also fire up notebooks. So it's a very rich environment, and allows you to do everything from your web browser and interact with the cloud. What I want to do is take you through just accessing a data set in the cloud. And I should first say that this wasn't developed alone. Luis Lopez was one of the people to kind of put an initial notebook together, and then Michaela Baig at both NSIDC, she developed this further for the ISAT2 Hack Week. So it's been kind of worked on there as well. So definitely not in a vacuum. I've included the link to this. I'm not going to run through all of the text here. You can follow along or look at it in your own time, and maybe use some of the stuff in here. What I want to highlight is the learning objectives in here, and kind of a roadmap to what we're going to do. So we're going to use this library developed by Luis Lopez at NSIDC Earth Data to do spatiotemporal searches for ISAT2 data and explore those results. This is the first step in any workflow to allow us to find the data we want for a particular area on the Earth or a particular time range. And that can sometimes be a little complex because we have to deal with Earth data login, we have to deal with credentials for working with the AWS S3 buckets. And so Luis realized that everything should be simple for us, and so he wrote this library to deal with a lot of those pain points. It also allows us to open granules using direct access, and I want to distinguish the direct access from just a normal download. The direct access within a cloud context can be thought of as essentially accessing the S3 bucket as a file system, in the same way that if you're working locally, you just give a URL or some file path to a data set on your local system, and that directly accesses that file. You're not having, when you're interacting with the S3 bucket, it goes straight to the object, the file object in that bucket, and accesses it. Then we're going to load that data into an Xarray data set. You don't have to use Xarray. There are other ways of accessing it. It just makes it a lot simpler. And then I'm going to finish off by just visualizing a point cloud using this library called hvplot. So I'm going to do this live coding because I think it helps to see kind of the process. So I'm going to get a pretty much blank notebook. You'll see some little ellipses at the top here. This is because the kernel that we're using is under development, and we needed to do some install of a later version of Earth Data. So I didn't want to trouble you with having to go through that whole procedure, and I just wanted to jump into running the notebook. So the first step, we're going to be working in Python. R is very similar in that you have to start loading some of the packages, importing some of the packages that you're going to use. So we're going to use this package Earth Data, and I'm going to import a number of methods from there. We're going to import something to authenticate that deals with the Earth Data login and credentials. We're going to import some search tools for searching data collections and data granules, and then we're going to import something that allows us to download or open and then load the data from the S3 bucket, the store object. We're going to import Xarray, and I'm going to give it a short name, standard short name of XR. And we're also going to import the hvplot Xarray module to allow us to plot. So while that's loading, and the reason it takes a little while is that hvplot is interactive, so it has to actually download a bunch of JavaScript to your browser. So it takes a little while to load. So there's essentially 4 steps. There's an authentication step that deals with essentially you logging in to Earth Data and getting Amazon credentials. Then there's a search step, and we're going to search for the collection first to get some information. That will then allow us to search for data granules, and then we're going to open the data and display it. So 4 steps to get to having the data in memory on your cloud instance. So the first step is authentication, and we do this using the auth object and just have to log in. Now there's 2 ways of doing this, or number of ways of doing this. If we just start this, we have using just a blank login call. You would just enter in your Earth Data login username and password. I can never remember mine, so I'm going to use a different method, which is to use a netrc file. You're probably familiar with this if you've used anything like wget. It's a file in your home directory that just stores login username and password. And this should work. So this gets you authenticated. I now have logged into the Earth Data engine, and also I have AWS credentials. And then we're going to just do a query to find ISAT2 data. Use it in this. This essentially uses CMR to find the ISAT2 data. And we're going to do this just by doing a keyword search. Okay, so you'll get to see all my typos in living color. So that ran. Let's see how many hits we get back, and we can make sure that we got that. So we got 44 hits, and then we can actually start to explore some of this data that we're getting back. And these are all collections. And I just want to, there's a lot of information in the metadata if you've ever looked at metadata return from CMR. So I just want to get short name and version, and I don't want to get all 44. I'm just going to look at the first 10. So we've made a query. The results of that query have been returned to this query object. And now I'm just going to say, I want to see what we got returned, what collections we got returned. And I just want to look at short name and version. And we're just going to print that.
You missed your S.
Yeah. Okay, so and this is a metadata record. It's not necessarily in a pretty format, but it provides the information that we need to go forward. It's got the concept ID for the collections. That's a unique identifier for each of those collections. We can see the number of granules within that collection, and we can see the provider. And then we have the short name ATL06, which is land ice height, I think. And we can see the version number, version 5, which is the latest version available. One thing you'll notice is that we have essentially the same data sets, both ATL06 version 5, but we have two providers, NSIDC ECS, that's the on-premise data holdings, and NSIDC CPRD, which is the cloud production data set. We're going to be working with data in the cloud, so we're going to be looking for concept IDs with NSIDC CPRD. And I want to demonstrate using ATL03. And so before we move on further, I'm going to just copy and paste that concept ID, because that's going to allow us to search for granules. And so we've searched for collections, we've found the information we need from that collection, Now we want to search for granules, and I'm just going to overwrite the query object with our granule search. We provide authentication again, and we have to do this at the moment because this allows me to search cloud data, because at the moment the ISAT2 cloud data is not fully public. I'll cover how you can access that at the end here. We're going to tell it that we want the concept ID that I copied from earlier. And I'm just going to do some formatting. I'm going to search for a temporal range. In this case, March. And we don't want to search for stuff in the future. And we're going to do and then, so that's the temporal search, and then we're going to do a spatial search using just a bounding box. And I have an area marked out for around the Juneau ice field in Alaska for this particular search. I'm reading off my iPad at the moment with the data set. So we've said what collection we want, we've said what time span we want, and we've said the area that we're interested in. And pretty quickly, we've got a bunch of queries. I have to use a slightly different method to see how many hits we got back, which is to check the length of a Python list, because at the moment the cloud data that is non-public doesn't show up in the hits. So we can see that we got 4 granules back, and we can explore that a little bit. And then and one of the nice things about working in the Jupyter Notebook is that we can use this little display method which actually grabs metadata from the query as well as links to images as well. So you'll see this showing up. It's not particularly well formatted, but it provides us with quite a nice display of the data. You can see that we've got a URL to the data. This is not the one we're going to use. This is for if you were wanting to download that data. We've got the file size, we've got some spatial information, and then we've got these little thumbnails here that show the data, ISAT2 data, and also the spatial extent of that granule. In the interest of time, I'm not going to click on those.
Yeah, Andy, I was just going to say, just a quick time check, just for those that have to run. It's almost 10.
Okay, yeah. So we'll get this data now, and this we're going to use the store method for. Again, provide authentication and use the open method. And then we're going to load it into an X-array data set. And I'm just going to load one of the files in there. Now the files are HDF5 files. So X-ray allows us to access that. We do have to give it a group, which is essentially a path to that data. And I'm just going to load one of the beams and get the height information for one of those beams. So while that's loading, this takes a little while because we've actually got to open quite a large amount of data, 6.25 gig. But the open method is essentially opening those file objects. So that allows those files to be read. And then X-ray, the open data set, is loading information from those files into an object that we can start working with. So it's kind of a two-step process that you wouldn't necessarily have to do where you're working locally. But we have to do it this way in order to interact with the S3 bucket. So we in pretty short time, we've got some data. We can see what that looks like in terms of file structure. You can see we've got the coordinate information, delta time, latitude, longitude, and then we've got a whole bunch of data here. I'm just going to plot up photon height using HV plot, and I'm going to use a scatter plot to do this, and we'll just use some small dots to demonstrate that. Again, a lot of points. If you look up here, we've got actually 19 million points here that we're going to be plotting. So while I'm waiting for that to come up, I guess we can open to questions or comments or discussion.
Thanks, Andy. I'm going to pop the feedback form in the chat right now, which is also copied in our slide deck, even though I feel like we should be have to wait for this is like the grand finale here to see the plot. But please.
The reveal. Yeah,
Yeah,
this is where the rabbit does not come out of the hat.
Andy, this is Thorsten. This was great, and it's just as easy as I used to do it, downloading the data and just running my own Python script. I'm just so you did it in a Jupyter Hub environment, and you just ran your script, and you had your Earth data link there, and you search. Where does the whole region US West 2 in that case, and and the warning that your compute instance needs to be at US West 2, where does this all come in? Because right now, all I saw, you're in a Jupyter Hub environment, you go to do an Earth data search, and everything is at your fingertips.
Right, yeah, that's a great question. So when you set up your Jupyter Hub, whether you do that yourself or whether you get a managed cloud kind of provider to do it for you, they will set up your compute instance within the within US West 2 where the data is. And you can specify that. So if you were wanting to use data in Europe, and it was on one of the European in one of the European regions, then you would set your compute instance up in Europe, right? You're not tied to any one region when you set up your instance. You can say, I just want to set it up here. So that's kind of the that's what you do before you set up your hub. You just say, I want it set up here. And that then allows you to, and then you have direct access to the S3 bucket with all the NASA Earth data. If you were not in US West 2, then you would have to actually download data from the S3 bucket to your compute instance. But it's just way easier to set everything up where you want to be working. Does that answer your question, Thorsten?
Well, it goes directly to my follow-up question. You know, so if I use data, ISA2 data that are in US West 2, and want to use, you know, some other data that are somewhere else. You mentioned Europe. Well, let's use Europe as an example. You know, I want to compare those with Sentinel-3 data. So
Yeah.
we can even keep it US-centric, and you know, some other data from the, you know, PO DAAC that are somewhere else. Then I would have to download the data, cross-load from the other bucket to US West 2. So that's where I got a little confused. Maybe it's just my ignorance here.
No, those are great questions, and I think those are things that we are kind of still working through what the best workflows are. I think so all of NASA data is in US West 2. So
I just saw Amy's
whether you're working with
too.
DAAC or whether you're working at NSIDC. If you want to get Sentinel-3 data that's stored on in a European region, then my approach would be to crunch down the ISAT2 data in US West 2 into a usable size. So you do all pre-processing there, and you would do the same for the Sentinel-3 data in another region, and then you're only having to move around small amounts of data. Now, there's going to be some analysis that you want to do that you might want to do at a really kind of low level, and that might not necessarily be possible. And I think that would then that's going to have to be something that we work through. But I think getting data to a size, a manageable size, kind of first, and then moving it around to your compute environment is probably the best approach in this case.
No, that makes sense. And I also saw Jeannie's texts that we NASA actually mirror Sentinel-1, 3, and 5 data, which is But it's also I completely get that as well. That it's kind of like, you know, us and you know Europe sharing, because we have different cloud environments, have different vendors, obviously, etc.
Yeah.
But this is super helpful and fantastic demonstration and presentation so far. It's wonderful. Thanks.
Andy, it's too bad the kernel crashed.
I know. You know, never work with children and animals.
Tested in a larger instance, if that would have helped here.
Yeah, I'm going to stop sharing so that you yeah, and sorry, I was looking at, there was some more questions came up in the chat. Yeah. Any other questions?
So I was going to say too, you know, we can walk through the survey, and I'll just kind of walk through those questions. I'm seeing 3 responses, so please, maybe you're still working through those, but you know, the questions are, you know, and maybe this will kind of spawn some discussion that we can continue to have. I know that some folks have to drop off at the top of the hour, but we can certainly stay on to continue chatting. So just some questions maybe for discussion prompts. You know, do you already work in the cloud? Does your group plan to work in the cloud? Do you feel more comfortable? And if not, you know, what will, you know, what would be helpful to get you there? Biggest challenges, and then other topics that you may want to cover. So we'll take a look at the responses, but if anything kind of prompted some further questions or topics you wanted to walk through while we're all together. I'm curious in particular about, kind of what I had mentioned that slide on the sort of accessing the cloud, and if you kind of see maybe some challenges there, or know of support that you may be able to get through an IT group, or not, and if that may be holding you back, or if there's other reservations there, or maybe some discussion kind of from a funding perspective, because that's the piece that I feel like, until our data are public and we're really working with more and more users, I personally don't have a great sense of kind of what those resources may, what resources may exist depending on where you're at, or if there's work in that area, or again concerns or barriers that you feel in that regard to actually get a cloud environment spun up.
Hey, Amy.
Yeah.
Instead of sticking this in the chat, you mentioned early access, and I know it's in the survey. Want me to explain that a little bit? Or were you going to do that when you go through the survey?
No, feel free, Kate. I was just kind of opening this up kind of for discussion right now. But I think we're planning maybe to send out some follow-on information for those who enter their name. But happy to walk through that as well right now if there's no other kind of questions or conversation around.
I was just going to say the high level bit of, not all the detail of, because we mentioned we've got some ISA2 data already in the cloud that's been migrated over, that we have been providing restricted access to for some folks, and before we have it fully public, and we would be happy to offer that to all of you as well, and can answer more questions about that. But when you see that early access question, that's what it means, is some access to ISA2 data in the cloud, so you can practice everything you learned today.
All right. Anything else? Again, we were able to kind of continue to stay online if there were any other questions, but certainly we're going to take a look at your responses. I really appreciate you kind of answering again related to sort of the challenges, and then also particularly what else, what are some other kind of specific areas that you'd like us to cover as we think about and sort of prepare for the September meeting, where I know today was more of an kind of Andy doing a little bit more of a show and tell, but we're kind of thinking about how to do something a little more interactive and kind of get more involvement, and maybe there'll be more feedback coming out of that. But if there's specific topics where you looked at like, oh, like what the heck is DAAC? I'd love to learn more. What does it look like to grab S3 data and Google Earth Engine? Something like that. We'd love to know, to help us prepare for that. So. Yeah, Jeannie, I see your hands up.
Hi, folks. This is Jean Benke. I guess I can't get my camera to work on Zoom, but that's okay. One thing, Amy, I was going to add.
We see you, Jeannie.
You do see me. I just
So
don't
be
see
careful.
Okay, good. I won't do anything. Oh, there I am. Okay, good. So one of the things I was thinking, Amy, while you were saying, it's not just about what kind of services. Maybe an issue right now is the timing, and maybe you need to give us feedback that you really need Andy Barrett to come back in like 6 months or something like that, because that's when you're getting ready for students coming back to school, or you need to have that refresher. So maybe you, Amy, you want that kind of time concept from our UWG members that help us focus. So it's not just maybe the services, it's more about, supporting folks in a timely fashion.
Yeah, absolutely. Yeah, it's a really great point. Yeah, any feedback on that I think would be really helpful.
What was interesting at the last UWG meeting, I think somebody asked, who's actually using, cloud computing capabilities, and I think of the UWG members, there were extremely few, and I forgot the number. It's a very, very small number actually did cloud computing. It is, I thought, was kind of interesting. And so when we talk at one point, when people rotate off and are being replaced, maybe getting some people on board who are actually using cloud computing capabilities, it may be a good thing.
Yeah, thanks, Torsten. I can respond to that. We are and have reached out to a couple people, and hopefully we'll get them on board. One is a new graduate that is transitioning jobs, so we need to get that settled first. But hopefully we'll have by the meeting at least one or two folks that have been working in the cloud actively and using it in their research. And I think that's, you said that was brought up at the last meeting, and I think that's a great point. And we'll really, kind of fill gaps in the UWG. So as I mean, as cloud comes along, more and more people will be using it. So maybe that's less of an issue. But I think still at this point, I think that's a really good idea to have people in there. So we are working on that.
The other thing I'd be interested in, and my job is to make you all do more work and more work there at Colorado. But if you could get access to one of the UWG members' university cloud environments, so you did a presentation from 2I2C's system that's on a managed cloud framework, but we also want to, try out how, if one of you was from University of Wisconsin or something, they have a cloud framework, maybe working with in that University of Wisconsin cloud framework to get at the S3 buckets in our system. I'd be interested in maybe if one of your UWG members wants to do that kind of collaboration. So maybe you don't know exactly how it works at your place, but we could get one of these experts at NSIDC DAAC to try it out with you, because very often we live within our own little structured environment. What do you think, Amy?
That's a really interesting idea. I mean, like I was saying, I don't, that's the piece that I feel like is the most sort of unknown to me. What others maybe have available or not. But yeah. I almost feel like the first question is something like that available to you today? I'm aware of sort of ADAPT. I know about some of the other like NASA, maybe larger scale, cloud opportunities. And in fact, we, through the NASA OpenScapes DAAC mentor group that I mentioned earlier, we've looked at I think it's the SMCE. They helped us set up a hub, and it's very similar. It's also a Jupyter hub. But there's definitely questions as far as, details on the Python environment and compute environment. But it's a really interesting suggestion to kind of see what is available or just their workflow today and what challenges exist as far as setting up a cloud instance.
Yeah, so that would be very cool. I mean, you could be like a proxy student at someone's class, like Nicole, or and then figure out for her how it would work from, her student's environment. I mean, eventually I'd like us to, maybe snuggle up with one of our NSF friends, because they have, AWS cloud environments, and Amy, we could probably find one of them to let us do a proxy on theirs, so we could figure out how to from that environment we would get at our stuff. Lots of great ideas. Just, just, finding time to do all these things.
Yeah, I think that's a great use case, Jeannie. NSF would be definitely one because, people do have researchers and students, are working under multiple projects funded by different agencies. So that's certainly a use case. And local university resources, HPC or cloud. We have, the University of Colorado has HPC resources, and we do have some projects working, researchers funded with projects working on that. So that might be a good use case that we could look into for the UWG. So Amy, maybe take a note for that to kind of explore that a bit as we start planning.
Yeah, absolutely.
It'll be a fun year, 2022.
I think on that kind of idea of various use cases, I think it's almost that we need not so much kind of demonstrations like I went through, but the kind of stories of these different ways of accessing the cloud and how they set it up, down into the nitty-gritty details of what are the cost implications, and how did you pay for it? How do you pay for it from your grant? How do you manage it if you have multiple members of your team accessing that? Because we've heard a number of kind of stories of people starting up a hub, the cloud service, and then allowing their users to, or their students or postdocs or graduate students to access it, and they've suddenly racked up large bills because of the way they've been interacting with the cloud. And I think kind of sharing those stories as well as kind of areas of concern and horror stories as well as success stories will really help people kind of navigate the transition to the cloud.
So I hope we haven't scared any UWG members off.
No, and actually
Yeah.
I was, I can paraphrase. I certainly don't have to share responses right now, but especially in looking at some responses as far as challenges, and there's some great feedback here, but I think some are sort of this question of do I need to move out of the programming language that I am comfortable in, particular MATLAB and Google Earth Engine, and that can be a challenge. And I think that's really something we, I guess, as across the US DISP at our DAAC as well, to really understand what was required or not. And I think those were some of the concepts at a high level that I was talking about, as far as what you currently do today and whether that really needs to change or not. MATLAB in particular is something, again, we've been working with kind of a scientist group through the OpenScape Science Champions program, who have some have MATLAB experience and are saying, hey, we're teaching in Python, and we've heard that too in various hack weeks that are kind of Python based. And so, do I need to switch my programming language? And really, the answer is no. But as far as especially, converging on one language to kind of start with to teach and build resources, it tends to converge on Python, just as we know that's kind of the most popular across the OS DISP. But certainly we've been talking about how to support other languages, and that was the kind of the RStudio example. And MATLAB is certainly another one that we've been talking about and figuring out how to support. So I don't think it's necessarily you must switch. But I think us kind of helping to answer those questions more directly, I think is really key. So I think that was a great comment that I saw. I wish we had Luis on to, because again, he's been, I know, maybe working a little more directly as far as this MATLAB case and sort of what isn't possible. But again, these are the things we're really starting to explore. A little different kind of out of the open source context though. So there might be some other challenges there. But again, I know we're looking at it and thinking about how to address it.
Yeah, I think that's one of the reasons, we obviously focus on Python is that it's open source, and MATLAB is not. But there are a lot of MATLAB users still. And so I think that kind of use case and being able to support that where we can would be very good. And then R is, it's the other main open source language that's being used in my experience anyways. And so it's less so, I think, in the remote sensing community, but in other communities, it's used quite widely. So I think having some materials and expertise in that and to be able to support that is important too. So like you said, Amy, I think broadening out is a good thing, and we're working on that. Yeah.
Yeah, and then the other comment that I saw was a really good one was sort of just a challenge of losing that time and needing to take the time to transition your workflow. I think that's absolutely valid. And I think that's where kind of some of these questions come into play as far as something that can be set up where you pop a link into a browser and sign in and you're off and going. Things like, kind of libraries that sit on top of, APIs that you don't have to code against. Those are all things we're trying to, trying to help ease the burden there, but it's really, really good comment. And visually browsing data and what that looks like. Are we losing that capability in the cloud? All right. Well, if there's no other questions, and I appreciate the feedback in the forum and the discussion today. And, of course, please continue to reach out to us, however you normally do through your venues. I know I'm not super tied in with the user working group, but like I mentioned, I think we'll send out the links to this recording and all the resources in the forum, maybe for those who weren't able to make it today and can watch and provide some feedback offline. All right, nothing else.
Yeah, thank you, Amy. This was great, and Andy, really appreciated it. I'm a little surprised so few UWG members actually showed up, but maybe that's just a scheduling problem or something. But yeah, the recording will be available, and that's fantastic. And wonderful job. Thank you.
Thanks, Thorsten. I appreciate your
Thank you.
back today. Yep. All right. Thanks, everyone.
Thanks, everyone. Bye.
Bye.
Thank you.